Thanks, Ruth. I appreciate that. Good morning, everybody. Thank you so much for getting up on a Sunday morning to come and hear me talk. My role at Navistar evolved from when I started. I came from a very customer retail-centric organization, and really, telemetric data isn't new. So I think one of the key attributes that we're going to talk about today, and the reason why I structured my presentation the way I did, is to leave a lot of discussion at the end. So there's no standard way organizations are utilizing telematic data or real-time data feeds. So I really left a lot of time at the end for open discussion and questions. So how many people are using real-time telemetric data in their organization today? Can I just get a quick show of hands? Is anybody using? Okay, great. Fantastic. Well, today I'm going to talk a little bit more about telematic data. But first of all, I'm going to tell you a little bit about Navistar. So, funny thing is we recently moved to our world headquarters in Lisle, and everybody goes, oh my gosh, that's that new navigation company down the street. A lot of people aren't aware that Navistar is the former International Harvester. So as an organization, we were founded in 1831 by Cyrus McCormick. So it was a very interesting conversation, especially with people from Caterpillar, as we both organizations emerged around the same time. So really, we have our international brand of commercial and military trucks. So those of you who are in the defense space, you probably know of our MRAP, which is slowly replacing the Humvee in the military. We have MaxForce brand diesel engines. We also are the market leader in the bus organization. So many people don't know that our market share is 23% with our IC bus offering. And Monaco RV brands, or recreational vehicles, which was recently renamed Navistar RV. We're a $16 billion Fortune 300 company, 17,000 employees across 5 continents. So really, what is Smart Truck? So Smart Truck was an internal project name, and we are officially branded On Command Connection. Really, it's all about downtime scheduling, right? Turning unscheduled events into scheduled events. When you think about our heavy-duty marketplace, really when you think about downtime for vehicles, you can equate that to true dollars for our fleets. When you think about fleet management, if you're managing a fleet and you lose a single driver, if he's down for one day with a vehicle in the shop, they lose approximately $800. If you have team drivers in a fleet management situation, you actually lose $1,300 a day for every day that vehicle is down. And on top of team drivers, it's become very strategic for organizations to have team drivers because of the high rate of margin return. So keeping fleet drivers and team drivers has become quite a challenge in the organization. So our answer is really on-command connection, which is leveraging telematic data to turn unscheduled events into scheduled events. So when you really think about the competitive marketplace today, as you can see, we are not new to the party. Volvo is probably the most mature organization when it comes to telematics data. They've been doing it the longest. Freightliner, obviously PACCAR, and then, of course, us, Navistar. So really, many organizations aren't talking about the warranty fraud or cost reduction aspects of their telematics projects. One of the big reasons is because people get that big brother feel when you start to talk about warranty and fraud analytics. So really, most organizations are doing it but not discussing it. So it's a big area of opportunity when it comes to telematics data. There are many key business drivers that are bringing organizations to the trough of machine-to-machine data collection. For us, when we started looking at the business case and the vehicles in our portfolio, heavier Class 8 vehicles presented the largest opportunity for us. So our focus on the big bore vehicle data set allowed us to drive through a high level of data detail. When diving into the data details, there are many value propositions for the use of telemetric data in the marketplace today. There is an equal emergence of customer-facing needs, internal intelligence requirements, market volatility in production, supplier quality, and lack of skilled labor for vehicle repair impacts both the organization and the delivery of a quality product to the customer. This is causing erosion of market share and accelerating the need for actionable real-time data. So here is an example of our feeds and speeds. This was our original calculation, which I'll talk a little bit about. Once the need for the real-time data is established, then the real work begins. Here I'm showing a sample of the initial calculation model built upon the proof of concept data feeds. I feel it's important to keep modeling feeds and speeds throughout the process of gathering the data requirements. First of all, it's often a fun exercise to see where you started up with your calculations and where you actually end up. So yes, I am a true data geek. So as you can see here, before doing any detailed business requirements, calculations, or designs, we're at only 14 gigs of data for 45,000 trucks in our first year. After technical design, business requirements, and business rule management, we estimated at 4 to 6 terabytes for the year for the same 45,000 population of vehicle. The key drivers for the dataset growth was the value propositions and the inherently involved our data model and storage schema. I'll talk more about the data usage and validation in a few slides. So avoiding the pig pile. So as good data stewards and keepers of the keys of the data and the architecture, how do you avoid what I like to call the pig pile syndrome? This is where every business unit you talk with wants every piece of data off of every vehicle. They don't know what they're going to do with it, but they want it. They want it in a dashboard, and they want to be able to ask it random questions and always spit out the right answer. So this is where the collaborative approach starts to break down. If they aren't going to get what they want out of the project, they're going to take their proverbial ball and go home. So how do you keep these critical players in the game? Keeping open lines of communication is critical. Also, creating a data staging roadmap was a great way to ensure they were being heard. This roadmap also serves as a critical component of communicating with your divisional presidents about how telemetric data supports the key focus areas they're driving. For us, this data supports our focus on quality and delivering value to our customers. So driving value through data identification. The foundation work put into a data staging roadmap is the basis of your data value proposition. There are two schools of thought around this. Many organizations, such as Navistar, where we have a diverse portfolio and varying complexity of vehicle data over the years of very diverse group and complexity of that data. Over the years, we leveraged a data consolidation platform, or EDW, such as Teradata. This platform allowed deeper dive historical data analytics, often down to the minutia. The second school creates a machine-to-machine collection model and summarizes that data to be commingled with historical data at a higher level. Both need to be supported by data attribute validation. Each piece of data you store has a value either today or tomorrow. Without a thorough investigation and return metrics on this information you're collecting, you just end up with a lot of data. And in this instance, sometimes bigger is not better. Larger amounts of data without rigor and value behind it become somewhat of a beast to tame. And though some may argue that storage is cheap, but processing time and cellular satellite time is not quite at that level of commodity yet. So we took a very simple outlook on the data we collected, prove the value, and we will collect it. This allowed us to create a flexible and scalable environment with the assumption that the value proposition will evolve and change. I wanted to touch on two data usage scenarios, which seem to be the topics organizations reaching out to me want to talk about the most: data prognostics and in-stream data management. Data prognostics are quickly becoming the holy grail for service and warranty applications. Being able to model and predict supply needs, warranty accrual management, shortening vehicle turn times at the dealer, and the list goes on. One of the drivers for prognostics is the use of historical data trends. This is an interesting discussion when you talk to organizations that are 100 years old or more. So understanding the expiration date on your data and its relevancy on business decisions is an important foundation for prognostics. Engineering master data management location is a key source for our prognostic data. Using your engineering data as a basis for your product performance and leveraging it with telemetric data pushes prognostics forward at a faster rate than building that knowledge again in a new data location. Conditional prognostics can help identify emerging issues and is also a key component to many NHTSA connected vehicle research programs on collision avoidance. In-stream data management. Once you have your prognostic algorithm in place, many of the data points you're watching for can be translated into data stream management activities. Some activities that can be managed in real-time data management is sorting actionable data and attaching a workflow to it. This can allow you to take near real-time action for high customer impact situations. It will also allow you to execute on a multi-layered data management strategy, which could include decision tree analytics that you expose to your customers. I'm going to talk very high level about the technical architecture that we put in place. This will be available as part of the presentation as well. One of the key components in this overall technical architecture, this becomes the very mature level of technical architecture for us as an organization. So this actually is our second phase of implementation. This really allows us to put an OLAP layer utilizing Oracle as a staging location before we put the information into Teradata. This actually was an exercise that was put together by our technical support team in partnership with Teradata. It's a great opportunity for us to make sure that we're utilizing real-time data, but also dropping and managing different levels of data as they come through the OLAP layer. So turning them into actionable items or turning them back into storageable items is really the basis of this technical architecture. Here's the integration points that I think are most important when we talk about the layers within our organization. So we have Java Web Services. Also, we're doing batch or mini batch loads, putting that into data stage and making sure that we're putting that into EDW, which is Teradata. Real-time request and processing real-time dynamic analysis is really in our subscribe layer and the SOA layer. So obviously when you look at streaming architecture, which I'll talk about in the next slide, SOA becomes important in terms of our publications. Here's a copy of our real-time streaming architecture. This is an important piece. I think one of the critical things organizations are really striving towards is really platform simplification. So when you think about your goals as an organization, our goal was to simplify the platform but still be able to support real-time data management. Here we removed the Oracle OLAP layer for our phase one with only 45,000 vehicles. We felt it was appropriate to make sure that we were able to handle all of the data coming in, but also not overload the platform. So in summary, there's not standard use telematics data today. In the future, we'll be seeing this data as table stakes as more attributes of telematics systems become commodity in the marketplace. As we drive towards open source application layers shared among open platforms and strive for safer driving environments, telemet data will continue to deliver. The importance of telemetric data and the value proposition for an organization to use that data needs to be continually in balance to drive the highest rate of return. So in summary, it's very important as you think about your real-time data usage in your organization to make sure that you're understanding the data attributes you're collecting and the value behind them. It was a real driving factor for us to be able to phase our implementation approach. So at this point, I'd really like to open it up for open discussion and discuss everything from choosing telematic hardware, airtime service providers, and also the data piece of telemetric real-time data. I was responsible for all aspects of that project, so I'm happy to answer any questions centered around that.
Good morning. So could you expand a little bit about how you collected that data and used it to plan the outage? The data was transmitted how and collected with what to plan your outage so that you can maximize the time on the road?
Sure, absolutely. So there's a telematics device on the fleet management system. So the truck itself actually communicates with what we call the electronics control unit on the vehicle. What we were able to do in partnership with our engineering organization was understanding the diagnostic codes that are coming off the vehicle and assign what we call a red, yellow, green schema to it. So green meaning continue down the road. Next time you come in for maintenance, go ahead and fix the issue. Yellow meaning we need to make sure that we divert you in the next X amount of miles to a local dealership to get things corrected. And then obviously a red, which is pull over immediately and dispatch a tow truck. The great thing is the way that we're leveraging the data that is coming off of the ECU is real time. We're feeding it into Teradata, and obviously we have a set of business rules that we use IBM iLog for. So we use iLog as a driver to understand the data that's coming across and being pushed into Teradata on two different levels. So the actionable items, which is red items, we actually have a person that physically calls the customer and says, this vehicle needs to get pulled over immediately, and we'll dispatch a tow truck. Other vehicles and other warnings actually go into a storage schema and actually get dispatched via text or email to the dispatcher of that fleet.
So the data coming in, the data's being fed